Hello everyone, in this video we'll be discussing about object-oriented programming. So the major purpose of C++ programming is to introduce the concept of object orientation to the C programming language. Object-oriented programming is a methodology or a paradigm in which we design programs using classes and objects, wherein an object represents a real-world identity such as a pen, a chair, a table, a car, etc. The main aim of OOP is to bind together the data and the functions that operate on them so that no other part of code can access these data except the functions which are defined within the class. So, what is a class? A class is a blueprint which defines the data members and member functions common to all the instances of that class. A class is a user-defined data type which has the data members and member functions. Data members are the data variables, and member functions are the functions which are used to manipulate these variables, and together they define the properties and the behavior which all the objects of that class will have. For example, a class car can have the data members speed limit, mileage, etc., and the member functions which a class car can have is applying brakes, increasing the speed, decreasing the speed, etc. What is an object? An object is an instance of a class. So whenever we define a class, there is no memory allocated to it. But when it is instantiated or when we create a class, the memory for each of the variables, data variables present defined in that class is instantiated. When a program is executed, objects interact by sending messages to one another. Each object contains data and code to manipulate the data, and objects can interact with each other without having to know the details about each other's data or the implementation of the code. It is sufficient to know which type of message is accepted and the type of response which is returned by those objects. Let's talk about encapsulation. What is encapsulation? Encapsulation is one of the four fundamental object-oriented programming concepts. The other three are inheritance, polymorphism, and abstraction. Encapsulation is defined as the binding together of the data and the functions that manipulate that data. In encapsulation, the variables of a class are hidden from other classes and can only be accessed through the methods of that current class. Therefore, it is also known as data hiding. Hiding the internal details and showing only the functionality is known as abstraction. In abstraction, displaying only the essential information and hiding the details is key. What it means is that we hide the implementation of a certain functionality from the outside world such that the person doesn't know how the thing is being implemented or is working. For example, let's imagine a man is driving a car. So what the man knows is to apply the accelerator to make the car go faster, apply the brake to make the car go slower, or to stop the car. But he or she is not aware of how actually applying the accelerator makes changes to the speed in which a piston of the car actually changes, etc. So in this way, the entire functionality of the acceleration is abstracted from the user, wherein he's only aware that doing such an action of pressing the accelerator accelerates the car. Inheritance. The capability of a class to derive properties and characteristics from other classes is called inheritance. So in inheritance, we'll have a subclass, which is the class that which inherits properties from another class. A superclass is the class whose properties are being inherited by the subclass. Inheritance supports the concept of reusability. That is, when we want to create a new class and we already have a class that includes some of the code or functionality that we want, what we can do is we can derive a new class from that existing class. By doing this, we are reusing the fields and methods of the existing class. Polymorphism. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. In C++, we have operator overloading, function overloading, and function overriding. So operator overloading is the process of making an operator exhibit different behaviors in different instances. Function overloading is using a single function name to perform different tasks. Function overriding is when we have two functions of the same signature present on the base class and the subclass. So which function will be called during execution depends on what type of functions they are and the method in which we are accessing those functions. Polymorphism is extensively used in implementing inheritance. So now what are some of the advantages of object-oriented programming over procedure-oriented programming? So OOPS makes development and maintenance of code easier because in procedure-oriented programming, it is not easy to manage code as the project size grows. OOPS also provide data hiding, whereas in procedure-oriented programming, global data can be accessed from anywhere. OOPS provide the ability to simulate real-world events much more effectively. We can provide the solution of a real-world problem if we are using object-oriented programming. Next, let's look into the code. Right. So what I've done here is I have defined a class. I've defined some functions, some member functions, some data members, and also I've created an object of that class, which is I've instantiated that class, and I'm trying to use the different member functions present in that class. So how we define a class is using the class keyword followed by the name of the class. So in this case, it's class car. Then we define and declare the different data members present in that class. In this case, it is a string called name, ID, the mileage, the total distance which the car has traveled, etc. Then we also declare and or define the different member functions which will be present in that class. So in my case, we have a member function called string get name, which returns the name of the class, name of the car, string get id, which returns the id. Here I have declared the different some some more member functions such as get mileage, which returns the mileage, travel, which makes the car travel forward such that the total distance which the car has traveled will increase, and and another function called get distance traveled, which returns the total distance traveled by the car. Now in C++, what you can do is we can actually define the function outside of the class. So, and this is done using what is called the scope resolution operator, which is these double colons present over here. Scope resolution operator actually tells to which class a particular a particular function or a variable belongs to. So in this case, what I'm accessing here is the get mileage function of the car class. I'm defining the function here to return the mileage. Similarly, what travel does is it takes an input of some kilometers which are being inputted, and the distance traveled will be increased by those number of kilometers, etc. How we create an object of a class is simply by using the syntax, which is the class name followed by the object name. What I'm then doing is I'm using the different member functions which we have defined, and also let's try and access one data member directly. So we notice that we encounter one particular error during the compilation of the program. We see, what do we see? We see that car has a member called name, which is private within this context, and we are trying to access it outside the declaration of the class itself, outside the definition of the class. So this is where encapsulation or hiding comes in, wherein we cannot actually directly access whatever members of the class we need directly, uh, because they are by default they are private in nature, which is they can be accessed only within the boundaries of the class. This is due to something called an access specifier, which is by default private. We see that the member functions over here are preceded by something called public, which makes the member functions available to be used outside the boundaries of the class as well. So these are access specifiers, which we will be discussing further on. So we see that we cannot directly access any data member, any private data member using the dot operator. So then let's compile the program again and let's run it. So we see that we had initially assigned it with a name called some name, and that's what we get returned as. Here we did not actually initialize the distance traveled with something, so we get any random value. What we should do here is make it 0. And here we see it as 0. Then what I'm doing is I'm making the car travel by a certain distance, and then I'm displaying the distance again, the total distance traveled by the car again, which is 199 in this case. So this is the basics of defining and declaring a class. It's populating it with some member functions, populating it with some data members, and making and declaring some other member functions to operate on those data members as well. Thank you.